Okay, this equation that they've given us is currently in point slope form. I hope you recognize that. It's currently in y subtract y1 form equals m parentheses x subtract x1 form. So hopefully you can see how those line up. But we want to change it to slope-intercept, which we know it needs to look like this, y equals mx plus b. So our goal is going to be to get it to say y equals. And that's going to be our final goal is to solve it for y equals. So just like we did earlier in the year, we need to take care of all parentheses and like terms and that kind of stuff. So we do have some distributive property. So we're going to distribute the 4 to both the x and the 5. And when we do that, we get 4x plus 20. Now, with the 4x plus 20, we no longer have any more parentheses. We don't have any like terms on the left and to the right, so we can get the y by itself. So if we add 3 to both sides, then that 3 goes away, and we're left with y equals 4x plus 23. And that is in y equals mx plus b form. And I hope you recognize that it's in the same form. So that's our answer. All right. Same idea on the second problem. Once again, they've given it to me in point slope form. So I need to change it to slope intercept. So I'm going to distribute the negative 1/2. Be careful with your computations. Negative 1/2 x, and then of course negative 1/2 times negative 10, positive 5. The last step would be to get the y by itself. So we'll subtract 2 from both sides. And that's going to leave me with y equals
negative 1 over 2x
plus 3. And that is in slope-intercept form. So take a few moments to look at 16, 17, and 18. That's what we're going to go through next.
Can I do the next one? Oh, can I do the 18?
I do 19.
You're fine. Take your time. All right, so she did the distributive property. And then after the distributive property, you get the y by itself. And it's in slope-intercept form. So nice job.
Oh, right here.
Talk.
Hey, Blueberry. What did it
All right, so we're going through.
do? How in the world do you like Grace Gary?
Plus.
First step, of course.
Y plus T.
Now, is that a positive 7 or a negative?
No. Negative, my
Negative
bad.
7.
I did this.
Okay, negative 7. So we did the distributive property. And then after the distributive property, subtract 1 from both sides. Now, it's actually going to be right here. Negative 7 minus 1 is negative 8.
Oh.
So, because they're the same sign, right? So negative
Yeah.
7, so negative 8.
Heck yeah.
Same process.
How come that toolbar don't show up on here?
Doesn't need to.
Did you cancel it out?
Same process. First step is going to be the
I
distributive
think
property.
this is the easiest stuff we've done all year.
Hush. Hush.
It hasn't even been a whole year yet.
Okay, the distributive property, then you get the y by itself. and you have switched it from point slope form over to slope intercept form. 60 minus 3. Negative 60 plus 3. 57.
Oh, yeah,
Got the
I had that on there.
I know. I recognize that the part of this shape that goes on BC is straight, and if I had a ruler or something, I could make it a long straight line, and I could write a line for that. We only want the equation of the piece of it, though. So just to recognize, what we're going to do is we're going to use our point slope form. That's the best way. So let's identify our points. Okay, we recognize we got this point here. What is that point?
B.
B.
Well, it's point B, but it's the point
3 and 0.
3, 0. And then we've got this other point here, which is the point 1, negative 2. Now, in order to write an equation, I need the slope and I need a point.
2 over T.
So let's find the slope.
What point would we use? You want to use the 3, 0?
Well,
or 1, negative?
We've got 2 points here, so we could use the slope formula if we want to, but
I say we use the one that's not
there's
gonna be-
actually a faster way. Because we have a graph, wouldn't it be easier just to count the rise and the run? So let's just count the rise and the run. And let's see if that works out a little faster. How much does it rise from point C to point B? It rises 2. And how much does it run? Also 2. And 2 over 2 is 1. So my slope is a 1. Now, I have a point. There's actually 3 points. You could choose this point if you wanted to.
Oh, yeah.
It doesn't matter.
I like the 3, 0.
Look, you have a choice.
It's not gonna
It's your choice. You get to choose whichever one you think is going to be the easiest. All right? So, Caitlin, why don't you choose a point? Which one do you want to do? The B, the C, or this middle one? Caitlin. So we're going to write our equation off of the point B. So we've got y subtract, what's the y coordinate? 0. Equals my slope of 1, parentheses, x subtract the x coordinate. And now I follow through and I distribute and I combine like terms.
The 1x.
So that's going to give me, I've got y minus 0 here. I don't need that. I can just make that y. That's going to be 1x minus 3. And look, you're in slope-intercept form. Okay? And I can do a quick double check of that. Remember, if we would have extended that line all the way out, is the slope really 1? Watch it. Rise 1, run 1. Rise 1, run 1. Rise. So it is. And is the y-intercept actually negative 3?
Yes.
It sure is.
No, it's not.
Oops, right there. So, guys, it does work out the same. So in order to write the equation that represents AB, I need the slope and I need a point. So I'm going to look up here and try to find the slope. I think because it's a graph, it might be easiest just to count the rise and the run. So if I count the rise and the run, it looks like it's going up 1, 2, 3, and over 1, 2, 3. Looks like it's a rise 3, run 3.
So it'd be 1.
So that would be a 3 over 3, which is exactly a 1. Nice. Okay?
Or an egg.
Once you have the slope, you just need a point. Now, you have multiple points to choose from. You can choose point A. You can choose point B. Or, since this is a nice pretty graph, I could actually choose these points in the middle too. I think I'm going to use A or B. All right, so Daniel, pick which one. Pick one of those. Doesn't matter. All right, so we're going to use point A. It doesn't matter. That's just the one he chose. So as I write my equation, I need to do y subtract y1. What's the y of point A? No, the y is a 6. The y is a 6. Equals the slope of 1 times x minus the 10. Now, this is in point slope form. I need to finish the problem in slope intercept form. So now I'll simplify it like you guys were doing just a few minutes ago. Distribute. And that gives me y minus 6 equals x minus 10. And then when I add 6 to both sides, I get my final equation of y equals
X minus 4.
x minus 4.
Woo! I'm pretty good at her.
So because we're looking for BC now, there's a couple ways I can do it. If you recognize some of your line information, you could skip a lot of work right now. If you remember about horizontal lines and you remember about equations. But if you don't, you can continue to use your point slope form. So I need the slope from C to B. So it's easiest just to count the rise and the run.
The rise is 0.
The rise is 0 and the run is 7. So if you rise 0 and run 7, what's your slope?
7.
No, 0 divided by 7 is 0.
Oh.
And that's where I was saying, if you remember that all horizontal lines have a slope of 0. Could have saved yourself a little work. That's okay. Now that I know the slope is 0, I can choose a point. Now there's lots of points to choose from. I can choose B or C or any of these points in between. They're all the same. Devin, you choose one? C. Devin says let's use C just because it looks easier for him. And he's probably right. It is pretty easy. So I'm going to go y subtract. The y coordinate is a 3 equals my slope, we just found out, was the m, a 0. So that's 0 times x minus 0. Now, just like before, same process, distribute the 0. Well, think about that for a second. 0 times x is 0, so that really wasn't much. And then 0 times 0 is 0. What do you have over here? It's all just 0, isn't it? Everything disappears.
Y equals 0. Y equals positive 3.
So y minus 3 equals 0. I still have to add that 3 to both sides. So my equation is y equals 3. And again, that's one of those spots where if you recognize that all horizontal lines are y equals a constant, then that might have saved you a little time on the equation. Okay? So I'm going to help you with one more. I'm going to help you with AC, and then you're on your own. What's different about AC compared to AB?
It's horizontal.
It is at a slant, but it's actually a little bit nicer. Remember, the equation, the form of a line we learned last year was slope-intercept form. And look, doesn't this actually cross the y-axis?
Yeah.
So if we're paying attention and we recognize in this situation the slope and the intercept, we can actually skip point slope form and go straight to the final answer, right? So let's do that. Because they gave us our intercept, let's just try to skip right to the final answer. I still need the slope. So we're going to have to count our slope. And as I count my slope, it looks like to me it's going up 1, 2, 3, and then it goes over 10. So it looks like my rise over my run is going to be up 3 over 10. Well, remember, since we're skipping straight to our final answer, since we now know mx plus b, we can skip the whole point slope one. I know my slope is 3 over 10x. And what's my y-intercept? It's the 3. Now, if you chose to do point slope form, you could have used 3, 0 or 10, 6, and you would have still ended up with this equation.